acceleration at point C is equal to acceleration at point C in the tangential plus by acceleration at point C in the normal direction. Okay. So what we know is acceleration at point C in the tangential direction is equal to what? So given to us that is equal to 2j, positive 2j. Okay, so we know that this is positive 2j. Okay, we still cannot determine this. We don't know that yet. Okay. Now, then we look at acceleration at point B, and we are aware that acceleration at point B, if we were to look at it, right, point B is going towards the left, so you have minus a, b, t in the I, right? And then ABN is pointing upwards towards the center of rotation, so we know that this is equal to A, B, and the J. Okay? So this information is important. Okay, so remember, pointing towards the center of rotation. Okay, alpha we don't know, RB relative to point C. Okay, so point C is the reference. So B, so this is equal to 0.25 I, okay, minus by 0.25 J. So again, this information is important to us. Okay. Why is that? Because we know that the distance, we are aware with the distance from here to here, right? We know this distance, and we also know the distance from here to here, right? So we know that this is 0.25. We're also aware that from here to here is 0.25. So reference is C, going to point B is positive 0.25 minus 0.25 J. Okay. So we know this. We know this. Next, we have to determine our omega. Okay. So we know that omega is equal to omega AC, is also equal to omega AB, is also equal to omega AD, and this is because points A, B, C, and D are on a rigid body. Okay, so we can use the IC method. Yeah, we can use the instantaneous method. Okay, so let me go to the next page. I realize that in the term test instantaneous method, not you don't understand, I don't think enough time to practice. Okay, it's not that you don't understand, it's just not enough time to practice. That's why today I decided to make the decision, like I'm going to stop not lecture on next, the last Thursday of the week. Okay, right, so we're going to use the instantaneous method. Okay, so this is our point C. Over here is our point A, and over here this is our point D. All right, and we are aware that we have a velocity over here going up at 6. Okay, so 2, 4, 6. Okay, so we know that this is going at 6 feet per second. And then another one coming down is going down at 2 feet per second. Then we draw a normal line for instantaneous center. And then we have a line coming across down here. So where it crosses, right? This is where our instantaneous center is. Okay. Then I'm going to specify distance now. Okay. So from here to here will be x. And the distance from here to here will be 0.5. Is it 0.5? Yeah, 0.5 minus by x. This is because the entire diameter is equal to twice of 0.25 and it's equal to 0.5. Okay, that's the only reason. So they all share the same gradient as you can see. Okay, so we have delta y or over delta x. All right. So we know that this will be equal to 6 over x, and then this will be 2 over 0.5 minus x. Okay. Then you come out, you have 3 minus by 6x. This is equal to 2x. Okay. And then over here you have 3, and this will be equal to 8x. So therefore x is equal to 3 over 8 feet. Okay. And is the answer valid? Yeah, the answer is valid, because if this is, it seems valid because x is less than what? 0.5 feet. If you form the equation and x is equal or greater than 0.5, start to panic. Okay. So now we know that VC is equal to omega C IC, right? And then we have a distance of multiplied by 3 over 8, right? So this is equal to 6. Omega C IC is 3 over 8. So omega C IC is equal to 6 times 8 divided by 3. 16 radians per second. And as I say, because velocity of point C is greater than velocity at point D, therefore omega will rotate in this direction, so omega will rotate in this direction. So method number 2. We are going to use vector analysis. Okay. VD, VC, cross R, D from point C. We are going to assume clockwise. Okay. VD, VC, clockwise, so minus omega CDK cross R from point C, so it's equal to positive 0.5 I. Okay. So what we have is minus 2j is equal to 6j. K cross I is positive, and then this is minus 0.5 omega c dj. I do it again. K cross I is positive, minus, okay, we are good. Okay, so from here you based on j component, it's minus 2, 6, minus 0.5 omega cd, right? So this will be equal to minus 8, equal to minus 0.5 omega cd. Omega cd is equal to 16 radians per second. And for the fact that it's positive, we know that this is correct. Either way, it works out well. Okay, either way, okay, both you get the same answer. Okay, so now we are very sure that this will rotate in this direction now. Okay, omega cd, or that is our omega. Okay, so now go back to our expression over here. Let me copy and paste the entire expression first. So the next thing that we are again very sure is our omega. Okay, so we know our omega now. And at this stage, I think I don't think we can assemble. Let me see. I don't think we can assemble everything yet. There are a few things that we are not sure. Okay. So the next thing that we are going to look at, okay, is we are going to wait. Let me see. Do I need to use that value first? Because sometimes when I do something, I might have overkilled it. Okay, so after knowing omega, right? After knowing omega, right? Let's focus on AC. Okay, let's focus on AC, and we focus on AC in the n direction. Okay, so we know that AC in the n direction, this is equal to omega squared multiplied by r. Okay, so omega is equal to what? We have 16 squared Hold on, bear with me. ACN. No, I cannot skip that step. Okay, I do apologize. Can you all wipe this out first? I cannot. I was skipping steps. Okay. Before we can do that, okay, we have to now find what is our ACN and what is our ADN. Okay, we have to find what is our ACN and what is our ADN. Okay, so ACN which will be equal to our ADN, and this will be equal to omega squared r, right? So now let me copy the diagram across. Now let me get this diagram across, then I will not be walking you around. This is where we have to be really careful. Now, ACN